right. Hey, thanks so much for coming to the OpenSCAD workshop. I know in the description it says 2 hours, the schedule says 3. I've planned for the most amount of time. So we've got a full 3 hours worth of content and exercises and things to do in this. I want to make sure you kind of got your time's worth. It's an iterative piece, so we're going to spend a lot of time. We'll start slow and move forward. So before we begin, let's just say who the heck am I? I'm Kyle. I work for AWS. This particular talk has nothing to do with what I do. I work with a Linux distribution. You can come talk to me about Linux and BottleRocket at the AWS booth if you're interested tomorrow. I also have a talk on immutability if that's of interest to you. If AWS would pay me to talk about OpenSCAD, I would gladly do it, but it's something I do in my free time. One of the things I learned about myself is if it is able to be programmed, I will program it. It's like a compulsion. I think many people probably share that here. And so OpenSCAD was really a kind of a revelation to me when I started learning about this, because I could suddenly take these skills that I had been developing my entire life and then turn them into stuff that surrounds me, right? So that's where I came with it. Although I have been doing CAD for many years. I started doing CAD when I was like 18. That was more than 20 years ago, so that's interesting. But it really changed when I got into 3D printing and stuff around 4 years ago. I had not done any 3D CAD, and I looked at a few pieces of software around the world, available to me, and I said, none of this works for me. And I said, what's this OpenSCAD? And the rest is history. So I do a lot of 3D printing. I do lots of kind of functional stuff. So yeah, I put this together, but I am assisted by Spot. You want to come up and say some stuff about yourself?
No, just kidding. I'm like Kyle. I'm an open source person at AWS. None of this workshop has anything to do with what they pay me for. So I'm just thrilled to be here and having fun with y'all. I've been doing 3D printing stuff and OpenSCAD stuff for about 10 years. Most of the stuff I make is not as functional as what Kyle makes, but it looks really cool. I have all these beautiful pictures in my mind and none of the creative talent to be able to translate them into things, but I know how to write code. And so OpenSCAD was like the perfect overlap of, I will write a program that makes it beautiful for me. So that's me. And this is his workshop. I'm just here to help out in any way I can.
Yeah, actually, I think that's a great segue. The way this workshop is going to work, I'm going to present some stuff. We're going to do some exercises. I'll present some more stuff. We'll do some more exercises. I want to get you going on this. It is kind of a more intro-oriented workshop, so if you've been using OpenSCAD for as long as Spot, then this might be entertaining. You might see something that you find interesting, but it probably is not going to tell you anything you don't know. But if you do have questions, I'm glad to answer them as best as I can. So before I begin, I want to know a little bit about your experience. So I'm going to do a little bit of a hand poll. Raise your hand if you've written code before. Okay. A few people have it. That's okay. It might be a little bit rough to start, but you'll get going on it. If you've written code for more than 2 years. Okay. A few people have. More than 10 years? Okay. That's weird that there was a lot of commonality between 2 and 10 years, so evidently there's people who have been writing code for a long time or not. How many people have used a CAD software before? Most. Okay. Have done parametric CAD work? A fewer? How about have used OpenSCAD before? Okay, so that was a weird overlap between parametric and OpenSCAD. So we have some people who've used it before. Like I said, what we're going to be doing is we'll look at how OpenSCAD fits in the whole landscape of things. We'll do setup and tour of OpenSCAD, what it looks like in the different pieces of it. We'll look at OpenSCAD as a language. This is the majority of this, is talking about what the OpenSCAD language is. We'll look at the 2D subsystem, geometric booleans, 3D primitives, and some more advanced modeling topics. About 70 minutes of slides if I'm optimistic about things, 90 minutes worth of exercises, and the rest will be a kind of capstone project for you to kind of spend as much time as you need on. Okay, cool. So what is with CAD? CAD is a very odd piece of the software industry. It's sold very often as a per-seat license and harkens back to the days of like shrink-wrapped software. It's very expensive. There's lots of different options out there. A lot of them have a freemium model like Fusion 360 or SolidWorks, but they're not open source software, and they have restrictions on what you can do with this, or potentially the number of different projects you can have open and things like that. Tinkercad is free to use. It's like a web-based tool. It's taught to children. It's quite nice, but it's very limited. SketchUp is used more architecturally for like house designs and remodeling and things. SolidWorks and Fusion are used more in kind of the engineering area. In the open source world, we have FreeCAD. It's a pretty nice piece of software, and it has, it's what I would say is it's a like design modeling piece of software, but it has some parametric capabilities. There's a recent kind of derivative of it called OnSale, which is kind of like a fork of it, if you will, and they're trying to kind of commercialize it a little bit, so it's kind of interesting. I think it does solve some problems that FreeCAD has. Of course, we have OpenSCAD we'll talk about today, and then there's Python SDF. Python SDF is like a library for Python that allows you to create models from it, but it's not itself its own language, right? A lot of people like this. I'm more of a domain-specific language. I'd rather do something like that, but it does have a lot of commonalities with OpenSCAD. In fact, sometimes you can look at it and go, the same code works between the two of them, right? So just, it uses very much of the same primitives. So let's go on and talk a little bit about the design process. I talked a little bit already about direct modeling. Direct modeling is what you might think of when you're using CAD. This is basically comes from the area of drafting. Like if you've seen this, like I was a kid, my uncle was an engineer, and they had these giant tables with these straight edges, and then they were like drawing with pens, and they had, my favorite thing is that they had an electric eraser that they could use to fully erase. I still want one of those. But a lot of the CAD software we see comes from that lineage, right? It comes from the idea of like using pen and paper, but we've then transported it onto a computer screen. An entirely different way of looking at this is parametric design. And I kind of looked into the history of it. It's really actually interesting. Antoni Gaudí, who is a Catalonian architect born in the 1800s, is the father of parametric design. So has anybody here been to Barcelona? Raise your hand if you, did you see the Sagrada Familia? Okay. He was the architect of the Sagrada Familia, and this is in the museum. I don't know if you saw this or not, but this is the design for the Sagrada Familia. The Sagrada Familia is a incomplete cathedral that is over 100 years old. The architect died because he like walked out in front of a trolley bus, effectively. He thought that it should stop because that's the right thing to do, and it didn't. It just plowed him over. But the interesting thing about it, what you're seeing here is the design of the Sagrada Familia. And these are ropes that have a little sandbag at the bottom of them. And this forms all the interior of the Sagrada Familia. And functionally, what's happening is here he's trying to get, I believe it's a cantilevered curve inside. And what he's doing is he's actually moving the 2 points where it's attached, and there's a weight at the bottom. And so all the design comes down to 2 variables. First variable is the distance of the string, and the second variable is the distance apart that they're anchored. And this yielded this on the inside, which is just incredible. This is the inside of the Sagrada Familia. And this is all parametric, right? And so what OpenSCAD is like kind of the spiritual continuation of these ideas, right? The thing to know is that we're not drawing today. We're not going to do anything that resembles drafting. Instead, what we're doing is creating a program that produces a design. We specify the parameters as an input to it, and then it gives us a 3D object that we can then manufacture as an output. So what does that look like? One of the examples I've used before, by the way, I did the presentation on this a couple years ago at this conference where I talked a little bit about this. This is reused from that, but we have a remote control for our TV, something maybe like a Roku box or an Apple TV. And if we consider design modeling, where we drew it out, and we said, okay, that's fine, we have a design we like, how do we go in and actually change the spacing between the buttons, right? In design modeling, what you would do is you would click a bunch of places, you would change the width of all of those pieces, you would then drag things around and get to it. Now, Some of these programs do have some sort of way in design modeling to provide constraints that do this for you. But it's a lot that you'd have to do to make this one thing, potentially hundreds of changes on big designs every time you want to make a small change. But in parametric modeling, what you're doing is you're making a series of variables that you can then change. So all you'd have to do is change the variable that defines the spacing, and it re-renders with all the changes that you need. So that's the fundamental difference that we're doing today. So we have written a program that will produce the design instead of a design that we have to modify. Everybody with me? Cool. Like, what happens if you want to draw an organic shape, though? Like, say you want to go and say, I need a 3D model of an apple that you would eat, right? That's going to drive you crazy. That is incredibly hard to do in parametric modeling because what you're going to have to do is figure out some sort of mathematical way to derive the shape. So maybe a Bezier curve or something else. That's going to be really hard. If you want to create an organic shape, maybe OpenSCAD isn't the right tool for you. You should look at something like a sculpting tool like Blender or something like that that more natively kind of manipulates that type of thing. Okay, so I've given you an introduction to parametric modeling. Let's get into OpenSCAD. Does anybody have any setup problems yet? Has everybody set the software up? I'm seeing nods. We're all good. Anybody have an issue? You guys are great. This is fantastic. Okay.
So I installed it, I didn't do any setup.
No, that's fine. That's all you need to do. Yeah. Yeah. If it's installed and you can launch it, then we're good to go. Yeah. Well, let's look at that actually. So if you go into OpenSCAD, and I'm going to try to do this, you should end up with a screen that looks like this. It won't say foobar in it. Let me change that.
Can we launch this from the terminal?
You can, sure, but you don't have to. You can also just launch it via an icon or whatever. It should work.
Launch it however you like to launch programs. It will work as a GUI app. It will work as a command line.
Yeah, exactly. So it will initially show you a box, and it should say like new or open, some sort of little splash screen that says OpenSCAD on it. If you just hit the new button, you should get to a screen that looks more or less like this. Is everybody here? Is anybody not here? Okay, fantastic. So, you should see several different areas on this. On this side, and this can be moved by having this like click and drag thing here. This is where you're going to edit your files, although I'll tell you I don't use this, and I'll show you how I do it. This is what's called the customizer. We'll get to this pretty extensively. And this is the console, okay? This is where it's going to tell you information about that. I do something slightly different. I use, and you can probably see this, it's probably not showing you much, but I use just VS Code, and then I use a particular plugin called the OpenSCAD plugin. And I'll actually, it's very difficult for me to see over on this side, so let me drag it over to my screen, and I'll show you the OpenSCAD plugin. Okay.
It's probably worth noting here that if you're not a VS Code person, this is not the only path forward.
You can use any code editor you want. They just happen to have a specific plugin for OpenSCAD that I can speak well to. Or you can use the built-in IDE.
All of my work has been native in the IDE, just typing in the code there, saving files as plain text and opening them back up.
The one thing that I will tell you is if you're used to using multiple monitors, the built-in IDE has very poor support for multiple monitors.
True.
This is why I use VS Code. I put my code on one screen and I see the display on the other. So if you want to use VS Code, this is the plugin that you can use. This is the guy who did it. There's a couple of them, IntelliJ, all the other. You can look on the OpenSCAD website. They give you some examples of code editor support. But most code editors that are popular will have some sort of support for it, and that's usually just like syntax highlighting and then integration so it will automatically reload. Okay? Let's just go back for the time being. To, not this.
What was the name of the plugin for
It is called OpenSCAD by ANTYOS. Should have a yellow icon. Antoyos? I don't know how to pronounce his name.
So there's a couple, written about,
Say again? Okay.
do we also install the OpenSCAD language support or just the OpenSCAD?
You just need to install the Antoyos OpenSCAD plugin that has the syntax highlighter built into it. It has everything else built into it. Okay. But you can work just as well in the native IDE. It's just I want to offer it as an option if you're interested. If you're a VS Code user, sometimes it can get a little hard. The key bindings are different and that sort of thing. But don't think that you're attached to this particular editor. Okay. All right. Did that. So let's dive into OpenSCAD as a language, okay? OpenSCAD is a programming language. A lot of people get it confused with a CAD package. It's more of a language than a CAD package. The one thing that's different, and I will switch back to this, when I create a model, let's just do this super quick. So I'll create a very basic model. Okay, so I've got just a basic model here. I am rotating it around. So dragging your left button around will rotate the model, and your right will pan the camera. But I can't do anything to this in this view. You cannot make any changes. You can't really fundamentally interact with it. This is only a viewer, okay? So keep that in mind. You're going to want to like click and drag. You're going to want to do all sorts of things like that. So, yeah.
They asked us to not turn the lights off because the video feed goes poorly.
Okay. I didn't hear that. Oh, it's on the friendly instruction sheet.
Sorry.
Sorry if it's washed out. Okay. So yeah, you'll be manipulating this, but you can view, but you can't touch, right? There's nothing you can do here. We'll be paying attention a lot down here to the console. So when I say look in the console, look in this area down here. And unfortunately, I can't make this any larger. So we're just going to talk about what's viewed in the console. I can't actually show you very easily and visibly. Okay. All right, so OpenSCAD as a language. One of the things I believe in teaching OpenSCAD is that you should learn the language first instead of thinking too much about how do I make an object in that language? How do I make a physical thing in that language? I want to get my notes up here. Bear with me for a second. Okay. So common examples around the web favor brevity over anything else, and I don't think that's the right way to go. As developers, a lot of times what we do is we start with a very small example, and then we make it bigger and bigger and bigger and more complex. And you're going to end up with a mess if you do that. You have to really properly structure your code. A lot of examples of OpenSCAD are just terrible pieces of software. So you see a model made with OpenSCAD, it is oftentimes a fine model. It might represent something really interesting from a 3D perspective, but a lot of times if you were to look at the code itself, it would never pass any type of code review. An example of this, has anybody heard of a Prusa 3D printer? Okay, so Prusa MK3 or below was all written in OpenSCAD. Like the entire design was designed in OpenSCAD. However, it's a garbage fire of software. If you take a look at that source code, your eyes will bleed. It is so bad. It's full of just magic numbers. There's just no rhyme or reason. There's why is that 17? I don't know, because it is, right? It doesn't make any sense from software point of view. If I looked at what Prusa was doing, I would say, I don't think there was any advantage to them using OpenSCAD the way they did it. Now, they have stopped using it. Prusa MK3 Plus and above, it's all done in Idea Maker. I think, no, Inventor is the name of the software package they use. They stopped using it. And I can see why. There's just no reason to, the way they wrote it. And there's other big pieces of software out there that are really bad. And I think that just shows that there's a lot of people who haven't learned the language fully. And the challenge really with OpenSCAD is not necessarily the syntax. It's pretty easy. The challenge is structuring your code and getting it right and understanding how you can use it to your advantage. So let's take a look at types and variables. Let's start from the very beginning, declaring variables. The simplest form is you have an identifier, the equal sign, and the value which goes into it, and you end with a semicolon. A lot of times people don't put that semicolon in because they're maybe used to some languages that don't require it. You will get a not very helpful error message from OpenSCAD. It does type inference by syntax, so you don't have to declare what type you're using, and it doesn't have any user-defined types. So it's pretty straightforward. There are 5 types in OpenSCAD. There are numbers, okay? Numbers are floating point numbers. You don't have to put the decimal point in it, but they're all floating point. We have Booleans, which are either true or false, and they're identified by the reserved word true or false. We have strings that are denoted by double quotes only, and they are Unicode capable. And then we have vectors, sometimes called lists. Vectors are kind of like an array where you have a series of elements in the vector, and then you can also have vectors that nest. So you can see here we have a vector that has 3 elements in it. The first element is another vector, and then we have a Boolean and a string. That's totally valid. You can go as deep as you want with vectors. And then we have an unusual type called a range. They are used in one specific context, but you can use them as variables. They look like vectors, but instead of being delimited by commas, they're delimited by colons, and they can either be 2 or 3 elements long, and they're only really used in 4 statements. Okay? There is one more type. It's called undefined. Undefined is just what it is. It is undefined. Okay. So now we're going to get our hands dirty on something. Let's do an exercise. We're going to take about 5 minutes, create 5 variables with compatible values, 1 for each OpenSCAD type, name them my and whatever the type is. So for example, we'd have my number, my string, my vectors, my range. And those should be singular, should be vector and range, but that's fine. Remember, strings use double quotes, vectors, and ranges start and end with brackets, and then we're going to use commas to separate things out. Okay? All right, so let's take about 5 minutes to do that. I'm going to put 5 minutes on the clock, and then I'll let you work on it. Okay? If you have help, we're going to circulate around. Go.
How do we define a vector? Is that the range? Is it like 0 to 1?
So vector is So one thing that I do want to say, we're almost out of time for this exercise. There is a cheat sheet if you go to help, and that will give you some extra help on what everything looks like. So if you go to help and cheat sheet, if you get stuck, that's a good way to look at that. Okay. So how are we doing? If you are still working, I'm going to go ahead for sake of time. Then we're going to go ahead to the next section. Okay. So that's a good question. So a question said, I said it rendered, right? Every time we hit save, it's going to render, but rendering and compiling are one and the same in OpenSCAD. So when we start putting geometry on the screen, it will render that geometry into something we can see or something we can then save and use somewhere else. Okay. Okay. So the question was, what's the difference between the buttons for preview and render? So the preview button will give you a quicker view of what's happening, and then there's a rendering button that is a final render that'll give you what you could use somewhere else and save out. Yeah, so we'll go into it a little bit more later on, but that's a good question. Okay. All right, another question?
So if I want to do this in IDE, what is the file name for OpenSCAD file?
Yeah, just .scad. And like, when I do it, for example, if you have the rendering set up in VS Code, if you hit F5, it will render in OpenSCAD using that plugin. Yeah. You can open it in both places and it will do the same thing. Okay. So we've learned a lot about the different types. One of the things we didn't really talk about is how we access that. Vectors are a little different. If you need to access a variable, you would then take that variable name and put it somewhere else. That's how you access it. But vectors require us to use square brackets to access elements in it. So let's walk through this. So we have a vector that has 4 elements, A, B, C, and then another vector, 1, 2, 3, that's nested in it. So on the line where it says V0, what we're doing is looking at element 0, and we're getting A out of that. You can see that in the console output down here. Element 2, here's an important thing to know. Since we're zero-based numbering, element 2 is going to give us C, not B, because we're counting 0, 1, 2. And then we're going to do a nested one where we're going to look at the third element, and then nested inside of it, the first element. So that means the third one is 1, 2, 3. That's this whole vector. And then we have another set of square brackets we can go in and look at the first one. So that's 0, 1, so that's 2. So that's how we get 2 down here. Does that make sense to everybody? It's pretty standard way it works in a lot of languages. There is a specific thing, though, that we have in OpenSCAD called Cartesian vectors. And Cartesian vectors basically are where we have 2 or 3 element vectors. We can then access those by the dot syntax of X, Y, and Z. By the way, I'm Canadian, so I'll say Z or Z interchangeably throughout this conversation. But you can see we're pulling that out. So X always goes to the 0th element, Y to the first, Z to the third. So that's how we get echo 10, 20, 30. Okay? It's just a shorthand. Now we're getting into the complex bit. Scope in OpenSCAD works almost differently than every other language on the face of the earth. So when you define a variable, you can define it multiple times, but the last one wins, not the first one. Okay? And a variable keeps a single value during its entire lifetime. This is kind of like language speak, and it may seem like gobbledygook, but it's really important. I'm going to get to another weird thing, too, and then we'll look at an example of both of these. Variables cannot be iterative because of that. So you cannot do x equals x plus 1. That will not work because the variable itself has one lifetime. So that doesn't make sense in this context. So this is where a lot of people stop learning OpenSCAD when they start hearing this, okay? There's a great reason for it. We're going to explore it. So in this example, we have x equals 5, We're going to echo that x, and then x equals 6. Okay? It's actually going to output echo 6, not 5. Okay? So this is a little bit weird. I know some people chuckling. What's actually happening here is x equals 5 is being functionally overwritten on line 3, but the way the OpenSCAD syntax parser works is it reads the entire file to get the values that you have out of it before you execute anything in it, right? If you're used to like old school programming languages, I started on Pascal, and we did var at the top, and we declared all our variables at the top, and then we wrote that. So think about that. It's just kind of like doing it for you.
So if you left out the x equals 5, that would still return.
100%, that would work. So you
So it's out of order by every other language.
by every other language. Okay. Yeah.
You said that sequentially the definition precedes the execution of output?
Yes. Yeah. Yeah. Very different, but just think about, in JavaScript, they have this term hoisting. It's a little bit like that, if you've ever used hoisting in JavaScript, where you have a variable, you define it down at the top, and then it could mess with you sometimes. But there's a really, really good reason for it. We'll get to it in a second. Okay, so let's go a little bit deeper on variable scope. Here's a kind of crazy example. So we have foo equals 100. That's fine. We're going to say if true, right? The if works just like any other language. If true will always execute. We're going to do if true again. Bar equals 200, echo foo, and then echo bar. Okay, so let's break this down. The first echo is going to get here, and that's going to say 100, right? That makes sense because it's accessing the higher order scope, right? And echo bar is undefined because that's in a lower order scope. This is not too hard. Let's move on to something a little bit more complicated. So foo equals 100, we did that. If true, foo equals 10, bar equals 500, echo foo bar. So what's going to happen here is this foo is going to say 10 because what's happening here is called shadowing. So foo up here still exists, but we just have another variable named foo in this scope. Bar is defined here. We can't access that down here, so it's going to be undefined. And we see we're ignoring that.
So you're basically only overriding it within the nested context.
Yeah, you're only overriding the nested context. Right. What creates a scope in OpenSCAD is a little bit weird if you have what's called an anonymous scope, where you just have curly braces that aren't connected to anything. The parser just ignores that. So you have to have, that's why I have this if equals true, or if true, so I know it will create a scope. If I was to remove that, if equals true, then I'll get the warning that there's a redefinition, and then foo would actually equal 100. Yeah. Yeah. No, actually, foo would still equal, yeah, foo would equal 10. Yeah. Down in this, down here, yeah.
So it's like it's coming from the top to the bottom and it's saying, let me look at all the variables, last one wins, now let me execute code.
Yeah. And that only works for the outer context, like for each outer context that you're talking about,
Yes,
right?
for each-
Yeah, each level, yeah. We had a question.
Yeah, so the first echo is just a foo, the second echo is again foo,
Yeah.
right?
Mm-hmm.
So you are declaring the foo itself, right?
Yeah.
And the third echo, which is bar, so is it basically, I'm trying to figure out that it's basically, maybe I'm not understanding this, that it's echo, so how many times can you have an echo? Unlimited times?
Unlimited times you can have echo. Unlimited times. But it has to do with, pay attention to where, you don't have to do the tabs here, but that's kind of, will give you a hint what's going on here, right? So foo is on this same level, so it's going to equal 10. And foo is going to, on this level, it's going to equal 100, right? Bar cannot access something that is in a deeper nesting of that scope.
So it's out of that scope of the level.
Yeah.
If we put an echo bar in that scope, it would spit out
500. Yeah. Okay. Let's talk about special variables, just because I know you're going to run into them. They start with a $sign. Built in, there's several ones that you'll see. FN is the one you're going to see a lot, which is the function, what's the term? Spot, help me out here. What does the F stand for? It stands for, it's the term is escaping me. But no, it's not fabulous. It's nice. It's the number of facets. Excuse me. I could not think of the word. Facet number, the facet, that's the facet angle. You hardly ever see those two, but you always see FN. That's really, really common. We'll look at it later. Preview is one that you'll see a lot. If you were in preview mode, so we had the question about what happens when you hit the final render, an F7 render. If you're in F7 render, that will be false. If you're in the F6 render, that will be true. So you can change different things. So maybe you have debugging code you only want to show in preview, or debugging objects you only want to show in preview. That'll work. It's really handy. Then we get to $T, which is for animations. Animations are out of scope for this particular one. It is really interesting. That's a time-based variable. And then we have the viewport ones. Now, I was creating this said you never see these, but I have used them extensively when creating the screenshots here, but it changes the camera angle for you. So it can be really helpful. And then you can create your own special variables. They are useful in some really specific contexts. I have a library I wrote in OpenSCAD, and it's really useful in that context. You probably don't need them until you get pretty deep into the weeds. Okay. Let's do an exercise. Okay, this one is a little bit different. Let me walk you through this. We, in the end, want something that says echo 1, 2, 3. Okay? But we're going to only use 3 different things to do this. We're going to have a number equals, and then you can put 1, 2, or 3 in that and end it with a semicolon. You can use if true blocks, and you can use echo number, but you can't say echo 1, echo 2, echo 3. Okay? So you should be able to do it with all these 3 things, and try to use a minimal number of lines. So let's take 5 minutes. Sorry? You can do it in the same file, doesn't matter. Just erase what you had.
Or leave them, it doesn't matter.
Doesn't really matter.
Variables aren't used, so.
Yeah.
So I'm using, says you can.
He did. All the rules lawyers in the room. That's right. But he's trying to get you to understand how variables change in the scope. So he wants you to define one a number and then change it in the scope and then echo it again inside the scope and have it echo it out. You got to watch these rules lawyers. They've all created vectors and they're just going, oh, I'll just echo, and we're done.
Yeah. Yeah.
I know, right? Yeah, right. Too clever.
So, what did you do? Say my number.
So, first thing we want to do, let's start by just defining our name.
Yeah, exactly.
Our new line.
Yep.
Define the variable a underscore number.
Okay.
And the first value we want to come out is 1. So go ahead and find it. Semicolon, finish that variable. So every line we put in.
Okay, so I did that and it worked.
Okay.
And I just changed,
Well, on new line.
like any of the my range, I just changed the range,
Go ahead and do an
E
echo.
range, and I compiled it and there's still no errors.
Yeah. It should be okay.
It'll still work then.
Yeah. Yeah.
So what you call these, when you put in the parentheses with the echo, can be anything.
Yes. Okay. Let's go ahead and take a look at the solution, because I think people were having problems with that, and some of that is my fault. It's all my fault. I created this world. So here's what I was intending for you to do. I saw a lot of people creating vectors, which is clever. Not what I was looking for, though. So what we have here is we have a number equals 1, echo a number. So we're using our if true block to create a new scope. A number equals 2, echo a number. If true, a number equals 3, echo a number. So that way, we have only used those 3 different things on the screen that we had before. So we never did anything different than these 3 things. But we were able to get it to go 1, 2, and 3 by defining scopes. You could also nest these if you were really interested in it. Okay. So this is a little bit of like trying to get your mind around it. These are all kind of trivial examples and something you're probably not going to encounter a whole lot. So do keep in mind what we have here. Okay. Let's move on and talk about operators and expressions. Thankfully, OpenSCAD is pretty straightforward when it comes to math because you do a lot of it. Plus signs, minus signs. We use a asterisk for multiplication, a slash for division. Percent is modulo. We probably won't do anything with modulo today. You do an exponent with the caret sign, and then you use parentheses for grouping. So it's pretty straightforward to most other programming languages. I don't know many that don't use these symbols. And the order of operations for math is the same as you would have in your grade 4 math class. You know, pet my dogs and sharks or whatever acronym you learned. Okay. Now we get into relational operators. Again, these are pretty close to what you'd find in most programming languages. So it either evaluates a true or false. So you have 2 values or 2 variables on either side of these. So less than, equal to, equals to, not equals to, greater than or equals to, and greater than. The one thing you have to know is there's no strict equality. So you can't say that this is something, like is it exactly this? That's not an issue in OpenSCAD the way the type system works. And then if you're trying to look at like the relational sorting between strings, then those are alphabetical. And vectors are element by element comparisons. So it's case sensitive, yeah. There's probably a name for the way it does that. I don't know off the top of my head, though. There's a few different ways of sorting. So again, you probably, if you've done much programming, you've seen these before. This should be straightforward. So logical and conditional operators, these are also very similar to most languages, C-based languages or some derivative of that. Logical and is the double ampersand. Logical or is a or sign, so you have two things that evaluate to Booleans, and it will return a Boolean. And then we have a logical not, which comes before the identifier, so that's just the exclamation point. Now, here's the one I want to spend some time on, is the conditional operator. So we use a relational comparison. We use the question mark when true, otherwise when false. So we use this colon to indicate otherwise. So an example of this, a greater than 10, question mark, then it would evaluate out to bigger than 10, otherwise smaller than 10. Okay, it's like an if statement, but it happens all in one language, or one line. Different languages have different ways of calling this. They call it a conditional operator in OpenSCAD. Okay? Any questions up to this point? We got a question in the blue shirt.
Does this work the same way for as a when you value return, or is it just like this example?
Yeah, so if you remember, like, scopes are different if you're using that if. Like, if you did this with an if statement, you would have some scope problems potentially, because you might be defining a new thing. So that's why this is particularly important. So it does return a value, right? You can't use this like a standard if statement. Great. It does not create a new scope. Okay. So this one will take 10 minutes to do. I want you to declare a variable that is a number called wall thickness, not a vector, just a number. Declare a variable named inner width with a number of your choice. These can be anything you want them to do. Then create an expression that multiplies wall thickness by 2 and adds inner width. Okay? Now, determine if the calculation from the previous step is equal to, or it's greater than or equal to 12. And then you'd use the conditional operator here and echo out a message describing the relationship compared to 12. Does that make sense to everybody? Okay. Let's take 10 minutes. And if you get lost and you're just frustrated by this, I will tell you the solution to all these from this point forward, and you'll be able to get the slides and see them later on if you need to reference them. So. Okay. Looking around, most people are pretty much done with this, or they're waiting for me to do the solution. So let's talk about this. So I have inner width and wall thickness as we defined in that. We have an echo statement. A couple people were trying to like return a value and do some extra stuff there, or put echoes in the middle of it. That's all we're doing here is returning this value directly into it. So you can think of it almost like an assignment, right? It's actually just returning it back in. So bigger than 12 or smaller than 12. This all works as you might expect. Wall thickness times 2 plus inner width greater than or equal to question mark. Is it bigger? Is 12 or bigger? Smaller? We're there. Okay? I think most people got pretty close to this. Let's throw some curveballs. So one of the key advantages of OpenSCAD is the customizer. Now, if we go into our interface, you should see on the right side, I don't have the editor up, but you can see that there should be a thing that says perimeters, okay? And you should be able to hit the little triangle and it'll rotate down and show you something that looks similar to this, okay? Now, if we change one of these values and hit enter, it will then give a new result. Okay? So our same code has gone in and changed. Even though we haven't changed the code, it has gone in and interpolated the values in. So the UI values are then put into the program itself, and each change recalculates. So if we go back to the example of the remote control that we had, that remote control is then being re-rendered. So this is where the weird variable scope, why it exists. Because we need to interpolate values into the code and keep them there. And this is one of the key features of OpenSCAD. This is the perimeters. This is Anthony Gaudí moving the two pieces and changing the length of the string. This is why we use OpenSCAD. But it doesn't stop at the UI. You can run OpenSCAD and it will generate files from the command line. I'll walk through. The negative, or the -o dash just means take everything and put it out to standard output on the command line. Don't worry so much about the command, the export format ASCII STL. We'll get to that later, but I just have to tell the renderer to do something if it had geometry. It doesn't in this case, so that's extra. Don't worry about it for right now. And then our file will be exercises.scad. And we see we have smaller than 12. So that's the equivalent of running that in the UI or the IDE. Okay? Now, that's not amazing. This is where things get a little bit interesting. So see, what we're doing here is we're putting in this -d. We can then define values that we want to interpolate into the code. Okay? So we can put in lots of values, 1 value, 2 values, whatever it has, and it will actually render out that correctly. So if we had STL, it would produce an STL as a file, right? We're not doing anything right now because there's no geometry to output. But this is where having that weird scope and doing everything from there goes. You have a question?
Right. So when you are passing on these values of interface, it will make use of replace the value of interface all throughout, or only the last one where you are just before the echo statement?
Yeah, so what's happening here is you can think of it, it's not exactly working this way, but you can think of it like tacking these on to the end of the file. And that's where we had that weird scope, and you're like, oh, why does it do something at the end? It has to hoist that all at the top. That's the reason that exists. And to be consistent, but that only works on the outermost scope. In inner scopes behave the same way. Okay. So now what I want you to do is take your last thing that you did and then use the customizer and see what happens when you start changing those values. So just take a couple minutes to do that.
Can you put the answer for 3 up? So
Yeah. If you just want to type that in, that's the answer.
So for this thing here, we're better off just leaving it inside the, IDE to install anyway. And we need to customize that to this design.
Yeah, 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 I would. I mean, once it's sent over, you can just customize it, that's all. The, VS Code doesn't actually know how to compile it, it's just handing it off, but OpenSCAD really works, so.
It's funny, because like, in the plugin, it shows like it's gonna generate the model right there inside. It's not gonna do that.
There you go. Is everybody able to do that? And OpenSCAD has to be in your path for this to work. So that's one thing that I don't want to get into setting paths. But you can do it from the OpenSCAD folder if you're on a particular operating system. Okay. Let's go ahead and take a look at modules and functions. Okay. So what's the difference? OpenSCAD makes a huge difference between modules and functions, and most languages don't make this differentiation. They have something the same, they accept parameters. We've talked a lot about parameters. They're inside the curvy parens, not just the regular parentheses. It says parents. Oh yeah, parents, yeah. In parens, that should be parents. Yeah, yeah, inside parents. Yeah, keep your parents out of it. So a function contains a single expression and returns a value. Okay? That seems pretty straightforward. The way we do it, we have function and has equals 1. A module, on the other hand, creates or produces geometry and has no return value. A module cannot return a value. Okay? Parameters work a little bit unusually in OpenSCAD, but thankfully they're the same between functions and modules. They're always named, but sometimes have default values. So for example, both of these are named, my module first and second. Okay? My module first, second equals 2. So your usage here, my module, this in this case, first is 1, second is 2 when we're using it. First is 1, and because we had a default value for second, when we're running my module, second will be equal to 2. But we can also override that, so then second would equal 3. Okay? They work more or less like variables inside the scope that you're creating. There's a few nuances to it, but I don't necessarily want to confuse you at this point. So if we want to call this function foo bar equals 5, bar plus 1. So in this case, if I called foo with nothing in it, it would be 6, right? So the syntax for function.
Go back there. So you're saying it would be, so the function foo bar equals 5.
Yeah.
The definition of the function is bar plus 1?
Yeah, that's the definition of the function. That's the expression that the function is referencing. So when we want to call that function,
So if I say x equals foo, then it would be 6. X would be equal to 6.
no. So if we were to call this, if we said foo 3,
But if I say foo nothing, the default is 5.
yeah, so it would be 6. Yeah, yeah.
If I say x equals foo, it's going to be 6.
X equals foo, yes, parentheses, yeah.
It will define a variable x with the value of 6.
Yes. Thank you. Okay. So the syntax is function, function name, your parameters, or parameters rather, equals, there has to be equals there, and a single expression ending with a semicolon. Okay? You cannot use curly braces for functions. It is a single thing.
Has to be all in one line.
It doesn't have to all be on one line, but it can't be multiple expressions. You can split those up with carriage returns if you need to. And it can be declared just like variables before or after they're called. Okay, so you can say foo, execute foo, and then define foo at the end of the file, and that's totally okay. That also throws people for a loop.
And also, if I declare the function multiple times,
Last one wins.
Fair enough.
And it won't even give you a warning for that, unlike variables, so you can override them. So let's give an example. We've been over some of these. So here, we're defining foo 1, 2 into the variable 1, and then we're echoing 1. So here, function foo first, second is going to return a vector first, second. But then I'm going to override it in the next line, first, second, and it's going to return second, first, right? Yeah, it's 2, 1. And it's going to not even complain a bit about doing that. And that could be used to your advantage in many ways, but especially if you have like libraries on top of libraries on top of libraries that are redefining things. But it can be a little confusing when you look at it. Now, there's a thing called let, and if you used OpenSCAD a few years ago, this didn't exist. This creates variable-like abstractions in the scope of a single expression in a function. So it exists between the equal sign, so your function declaration equals, then you have the let, and then your expression, right? The order becomes relevant and is different than variables inside the let. So I'll show you how that works in a second. So function foo a, let b equals 1, let c equals b plus 1, and then our expression at the end of the function, the actual definition is a plus b plus c. So a is the value we pass in. B is always 1, so that's going to be 1. And then c is b plus 1. So let's say we did foo 10. It would be 10, 1, 2. You see how that's working? Make sense? These are a little bit different. Order does matter. So everything we learned about variable scope doesn't apply inside the let modifier. Okay? But it can be really useful. Before this, expressions in OpenSCAD were kind of useless because they were really complicated usually. Okay, let's do an exercise. 5 minutes on this. Create a function that doubles a parameter and then adds 1. Okay? So if we pass 6, we'll get a 7 out of that function. Okay? Oh, 3. So I said 3. You're right. Spot got me. Pass 3 in. It will double it to get 6, and then add 1 to get 7. Did I misnumber them? No, it's just like OpenSCAD. The order doesn't matter.
Off by 1.
Off by 1. I think I had an exercise 4 and I removed it.
Exercise 4 was the command line.
Oh, that's right. That's right. It was like using the command line or using the customizer. Yeah. Okay. So use let in the function to store the double parameter value. So you would store 6 in this if you were passing in 3. Pass in the values of 100 and 0.5, and then echo the results of each one. And here's a stretch goal. Create a function that can double by default, but then optionally multiply by any arbitrary value using a default. Let's take 5 minutes.
So defining the parameters are like this. So I would say function, and then I'd say a, right? And then, or I'd say e equals whatever. So you say function. So I have to say function. And then the name of the function. Yeah.
Let's take a look at the solution to that. Okay, so I did the stretch goal. Let's look at our function at the bottom. I call mine multiply, add 1. So I have one parameter called n, and then I have another one with the default, multiply by. We have our equal sign. I'm doing this let here. So multiplied, this is me in my naming scheme here, n times mul by, so that's n times 2. And then I'm going to be able to take muld plus 1. Everybody follow me there? Here on the first line, 100, we're using a default value, so that's going to equal 200, and we're going to add 1 to it. Same here, we're adding this that comes in, this is n times 2 plus 1 equals 2. And then what I can do, the stretch goal here, I've changed the mul by 3 instead of 2, so 3 times 3 plus 1 equals 10. So we're able to use let here just to add a little bit of syntax sugar on top of it. Okay. So now we're moving into modules. Modules are very similar looking, but they are in practice quite different. So we start them with module instead of function. We do the same parens, and then we have our perimeters inside of it, parameters. Then we have a single child and a semicolon. And then here, we can start using curly braces here if we want to have multiple children. Now, I said children. Children have a very specific syntactical meaning in OpenSCAD. Children are things that create geometry. We have used a module all along. Echo is a module. It creates geometry by outputting to the console. So not really geometry, but that's how it's shown. So it's a little special for a variety of reasons. The most important thing you can remember is modules cannot return anything. So you have no return value on a module. A lot of people want to do that. I have wanted to do that myself. There's no way to do it. So let's take a look at a simple module. So we have defined a module here. It's kind of nonsense. My module has 2 parameters, first and second, and we're going to echo only the second. Here we're going to run the first one, my module 1, and that's going to have undefined, right? Because first is not being used when we're echoing it, so that's why we get undefined here. We're even calling it by name, so first equals 1, first, undefined, down here. But then we use the second name parameter, and we call it to foo, and it's going to echo foo. So here I didn't use curly braces, but I could have used curly braces. It's fine. If you have 1, you can just create a module with only 1 child in it, and that works. Okay. That makes sense to everybody? Let's think a little bit about an exercise here. Create a module called someone says. Okay? So module someone says your parameters. Your parameters are name that defaults to your own name. So mine would say, name equals Kyle. And then you have message, MSG, without a default. So then you will want to invoke it with the parameter hello. And then it should say hello Kyle on 2 lines. Then I want you to invoke it by talking to your neighbor and finding out their name and putting that in the name value. And don't set any message. And what will happen there? That's part of the exercise. Okay? So you should say, for example, if my neighbor was Spot, what would it say? I don't know. Okay, let's take 5 minutes.
And I think the part that's missing is that the module should be echoing.
Yep. Yeah. Yeah. But all it's there, so that helps to give you a hint. Okay. Let's take a look at this. Battery run out? Oh, that's why. Okay. Let's look at this exercise. It should be pretty interesting, but so we created our module down here. Someone says is the name of our module. I put in my default as my name, and message was just a parameter that we could bring in. So echo message, echo name. That's all we had to do in this particular one. So up here we say hello, message is hello, and by default it's going to bring in hello from there and my name here. If I put in spot, it's going to say undefined because message is not defined here because we just left it here without a default value, and echo spot. So you could change those names and define both of them if you wanted to, as you need to, or one, or whatever. The defaults are really, really powerful in OpenSCAD, and you can use them in a lot of cases where you have like something that you want to create, but you don't know everything just yet, and then you will go in and use customizer values to make changes. Okay, so now let's actually make some geometry, things that we came here for. We didn't come here to add numbers and create echo statements. So there's two parts of OpenSCAD. There is a 2D subsystem and a 3D subsystem, and they are both valid, and you'll use them for different things. If you look at the screen, you'll look at something and you do it in 2D, and it looks like it's there, but there is a nominal Z or Z value added in the preview window, but it isn't real. It's just an illusion. So when you try to print something like that out, it won't render. Something I haven't mentioned, OpenSCAD is technically unitless. If you just export the rendered files as is, they will produce in millimeters, but you can use feet or whatever you want to. There is no intrinsic measurement included, right? Just assume millimeters for the most part, but technically it is unitless. Okay. Another thing that's a misnomer, we're going to use the word square, and it's going to create a rectangle. That makes me irrationally angry. I don't know about you, but I wish they'd called it a rectangle because then it could make a square, and it would still be geometrically correct, but people are lazy and they don't want to type rectangle, I guess. You give it a size, which is a 2-element vector. Remember, vectors have square brackets, and then they have multiple elements in them. And there is an optional parameter called center. And what that will do, by default, if you don't, center is false, and center is false by default, the X and the Y will grow in the positive direction. If you set center to true, then it will be the center point, the middle of the axes, will grow in either directions. I'll show you what that looks like in just a moment. So, here's our first piece of geometry. We have defined width and length here, and then we're putting them into a vector. You have to have these square brackets, and that will produce this. And you can see that this is 10 and 20 right here. Now, this is not centered, but if we were to go in and add the center, we can see what's happening here. So I've just added center equals true. So instead of starting right here, it starts and it moves out. So our width here is defined along the x-axis. So that's going to 5, -5 and +5. And the length is 20, so it's +10 and -10. And something to know, if you ever get confused where you are, the dashed lines are negative and the solid lines are positive. Okay? So, the most fundamental piece of geometry is doing that. Now, that will create something either we saw as the anchor point being the center or the anchor point being the corner. We don't always want to do that, obviously, so we need to move things around. So we move things around with translate. It changes the position of child geometry. So we're now talking about a new concept of having geometry modules that have children along the X, Y, and Z plane. It accepts a 3-element vector for the position or a 2-element vector. So you can, if you're working in 2D subsystem, you can just say X and Y. So the first 0th and 1st elements. And you can nest these as much as you want. There is some performance penalty, but until you get to very complex models, it's not relevant. So, a couple things going on with this. We're expanding out here. So what we've done here is we've taken our square and we've put it into a module, right? So now I have my square as a module that is getting length and width from the values at the top. We can see here we have this weird percent sign. This is actually a pretty useful little thing in OpenSCAD. This is a debugging syntax, and that makes something transparent. So we can see that's this piece here. And then we're translating from here. So in this case, we're doing a little expression in our translation value, width divided by 2, and then we have a negative on it, which is going to put it into the negative value. So it's effectively multiplying by -1. So our width value is 10. We are dividing it by 2, so that's 5, and it's going to -5. So you can see that here. So that's where we're getting this translation value. And then the length, we're multiplying it by 0.25, same as dividing by 4. And so we can see what we're doing here. So we have that 20 divided by 4 is 5. And we can see we moved it up. Does that make sense what's happening here? This weird stuff here is something we'll talk about later, and it's very important, but we'll talk about it. Don't worry about it at this point. Say it again. The thickness. So there is no thickness. It's all an illusion. We just talked about this. It's 2D, right? We're in the 2D subsystem right now. We'll get to the 3D subsystem, and we'll talk about how you go from 2D to 3D. But this is an illusion. This little corner here is just in your mind. Forget about it. It doesn't really exist. Okay? Any questions? Yeah. Say again what translate does. So translate right here is moving this piece by a specific number of units. So yeah, we're moving it this expression's worth in the x-axis, and then this in the y. See? It's a built-in module. Yeah. Okay. Question? Yeah, so translate, the thing about translate, I said it could be nested. So if you're just translating at this level, it's going to start at 0, 0, right? But if I nested it in, that translate would then be translating off of that translation. You could put translate 25 down, and it would still be translating off of various spots. Okay. Does this make a lot of sense? I have an exercise here. I'm wondering if we should skip it just for time purposes so you can move on to more interesting things. Who here wants to do a translation and square exercise? Raise your hand if you want to do the exercise on this one. Okay. One person does. Sorry. I think the majority wins in this. If it was a little closer, maybe. Let's go ahead and move forward on this, though. I'll show you what I'm talking about, okay? We'll go over this so we won't waste a few minutes. Okay, so this is what I wanted you to do. Create these 3 squares using these predefined values. So let's just go ahead to look at the solutions to this, and I'll explain it as I go along. Okay, so we have that, we brought that in. Now I want to create this particular square. So I do that with no translation. Here's my square. We defined this earlier on. Okay, so that's the lower right-hand version. We just created that. That's the kind of natural state of that object or that geometry. Okay, so then what we're doing width plus spacing here in the x direction, and that's coming out with my square. So that is the lower right version of this. So width 5 plus 2, so it's going to go over to 7. So that's this one. And then down here, we're doing this again, except we're doing both the x and the y translation, creating the upper one. Okay? Now, there's more than one way to solve this problem. Here, I've solved it in an alternate way by nesting translations. So see how this is repetitious? Let's eliminate that by doing one translation, running my square, and then translating that one again. So kind of an interesting jump. Okay. So now let's go into everybody's favorite flow control, the for statement. It's pretty normal. There's a couple weird things about it though. So we have an iterator value that would be like I or whatever you want to call it, and then it equals to a range. And unlike in a lot of languages, we can actually store that in a variable, so we use that range that we had before with the colons in it, and that can operate on a child or many children. Okay? So we had that range type, and it becomes very useful when you think of it in context of for. So start, colon, end, or start, colon, increment, end. Okay? So this will say how it will iterate through the for statement. Here's our example. For I equals 0 to 2. Okay? So that's going to echo I. Echo 1, 2. Straightforward. Seems pretty similar to most languages if you've done any programming. Now we can use the increment to skip steps. So unlike walking one step up the stairway at a time, we're going to walk up 3. So 0, instead of going to 1, it's going to go to 3, and then it's going to end at 6. Now the thing to remember here is that 6, the final version, it worked. Hey, folks. Hey, stream. We figured it out. Okay, and I think it seems better even. Okay. So, does this make sense to everybody, what's happening here? Lynn will give you the total length of it, but 4s are inclusive, so you're going to start at 0, and you're going to want to do a -1. Okay. This is a really cool exercise. I hope this is something that you're going to be able to really knock out of the park. We'll give a little extra time than 12 minutes since we didn't do the last one. So you're going to create a bar chart, this bar chart, using for, square, and translate. Your data is here, 37.5, 91, and 58. Each bar should be 10 units wide with a spacing of 2 between them. So you should be able to use, you define your bar width, you define your bar spacing, you bring this data in, then you use a for statement to iterate over and translate in the right squares. Okay? Let's take 12 minutes to do this.
Question on the previous one, the
Yeah.
number 7.
Yeah.
When it had the spacing, does the spacing mean the empty space between the objects?
Yeah.
It does.
Well, so spacing has, like, this is just how I'm saying that there's no, like, syntactical meaning to spacing in this case. So you could call it,
So it's not the thickness,
no, no. Spacing would be, in this case, spacing is, and I'll show you,
the empty space.
empty space between the bars.
Yeah. So so that one and this one are still 2D?
These are still 2D.
2D. Is there any way we would, aside from looking at the results, is there any way we would know, looking at the code, that it has to be 2D or it has to be 3D?
Yeah. Well, in this case, we're using square, which is always 2D. Okay? We'll talk a little bit later in the next couple of slides about how you change it from 2 to 3D. But square, and there's another reserve or another module for doing 3D work.
And what would be in 3D, what's the third dimension that we don't have in 2D?
The Z or Z dimension.
Z.
Yeah.
Okay, so if it has Z, it has to be 3D.
Yeah. But for the most, there is a few exceptions to that, but yes.
General rule.
Yes. You can have multiple planes of 2D, but 12 minutes on the clock. I'll circulate around and get questions. walking around, I see people making it a little more complicated than it needs to be. So try to simplify. Why did I fall asleep?
So even if I have more than but no silicone. Ready to silicone? Okay, folks. Some mini valiant efforts. People got real close. I'll show you what's going on here, and we'll look at a couple different ways. I didn't even bring up the challenge where you wanted a negative element, because it actually makes it much more complicated. So let's actually look at what it does when we want to do this. Okay, ignore this bottom piece. That's the challenge, the stretch goal. So that's all you needed was 3 lines of code to do this.
So we have our definitions. That was provided to us. Bar width is 10, bar spacing is 2, and here's our data. Like, that stuff was provided. So we're going to do a for statement, and we're doing a for statement to get over the length of data, not over data. This was the common problem I saw a lot of people trying to do. They're trying to do a for statement like a for each statement that doesn't really exist. It does exist, but it's not in this way. There isn't each statement, but you have to get into list comprehensions, which is way beyond the scope of this. So we're doing the length of data. So we're saying, okay, we're going to do 0 to 3, because we have 4 elements here. If we were to pass in 200 elements, it would still render out a bar chart correctly on this. Then we're going to translate by bar width plus bar spacing. So bar width is 10, bar spacing is 2, times I, right? So we have I 0, so that'll give us the first one, times 2, so bar width, so that's 12, times 2 would be 24, is where the next one would start, so on and so forth. And then we have bar width, and then data I brings in the height in the y coordinate. Okay? There's a few things that people were working on it. I think if we had enough time, people would have got there. Now, here is where the kind of stretch goal, this is a pretty big stretch goal. It all looks the same, except I've added in for y, because we wanted to make it negative. Like we had a negative value, how would we appropriately do that? We can't have a geometry with a negative size. That won't work in OpenSCAD. So what we have to do instead is basically shift it down in the y dimension, and then alternately, so we have this with this comparative operator. We have to use this, I didn't even go over this, but if you were digging far enough or looked at other similar languages, we take the absolute value of that data and bring it up. So functionally, we're drawing the same size bar, but shifting it downward if we wanted to do a negative value. But that's pretty advanced. So this is what you were kind of aiming for, this top box. Okay. That's okay if you didn't quite get there. That's one of the harder exercises that we had. Let's talk about circles. Again, we're still in the 2D subsystem. Here, it's a 2D circle. It's not a cylinder. It's always, by default, positioned at the center point. I believe, actually, that is technically incorrect. I think you can provide center false, but you almost never see that. And you either provide it a diameter, so the full width across the cylinder, or a radius halfway through, one or the other. And then here's that FN, the number of facets. That represents smoothness. We couldn't, Spot and I are both, our collective nearly 15 years experience could not come up with that word earlier in the presentation.
It's just the magic variable that makes your model.
Just make it FN higher. Make the FN higher. So here's an example. We have a diameter of 5, and we did circle diameter 5. This is with the default number of facets. See how chunky it is? It's technically an octagon. And it's based on the size. So as you get larger, the number of facets gets larger, but there's kind of a limited number. Anyway, you see this sort of junk, you're going to want to increase your FN. Then we're translating by D in the x-axis. So remember, we're doing center point to center point, so it's going to say its width of 10. So we're going to translate 10 over, so it's going to give us this 10 right here. We're going to create a new circle. I did this by radius. You could easily put D equals, but I want to show you what radius looks like. It's the same thing. It's radius and diameter. They're just half for one or another. When I do everything, I use diameters. I don't know why radius is loved by mathematicians, but diameter is more practical in my opinion. And we've increased the FN to 30 to give you this nice, smoother value. Now, I talked about performance. FN values look great, but they are going to kill your performance when rendering. So a lot of time what you'll see me do is I will use the other special variable preview. So when I'm working on this, I'll just kind of like move around with a low FN value. And when I go to render, I'll put that FN value through the roof so I get a nice smooth print. All right? Okay. Let's go back to a little bit of theory. OpenSCAD is a constructive solid geometry tool. This is a little bit different. When you are creating geometries in 3D, most of the time what you're seeing on your game or whatever is a collection of triangles that have no like volume to them, right? They are just triangles that are placed on a set of coordinates. If you're using Blender, you're going to create meshes. Mesh Mixer, you're going to create meshes. The problem with that is many times that cannot exist in the real world. OpenSCAD exists primarily on things that can exist in the real world. So all the things you make in OpenSCAD will hold water, as they say. If you create something in Blender, if you were to somehow be able to put it into real life in its exact representation, water would just pour out like a sieve from it. So it's very different. But because we use constructive solid geometry, we can use Boolean operations to create almost any shape under the rainbow. The Boolean operations that we're using are things like unions, differences, and intersections. If you've ever been on a database, you will know these terms very well. If anybody's on the Postgres track, we're not talking about left outer joins or whatever they talk about in that track. You can nest Boolean expressions to create practically anything. So this is one of the really hearts of it. We talk about circles and squares and whatever. This doesn't really give you much, but it really makes sense once you start putting these and mushing them together and subtracting one from the other, creating intersections of them. So the first one is the most useless. That's a union. The reason it's pretty useless is because this is something we do implicitly all the time in OpenSCAD. If we have two volumes that overlap in any given space, from OpenSCAD's perspective, they are functionally one solid geometry. If you were to output it to STL, it would be the same thing. So here we have a union. This is an explicit union. If I was to just take this out, it would render the same shape. I'll show you where it's useful in a minute. So we have a circle of diameter W, and that is on the center point, so it creates this circle right here. And then we have a square with an X and a Y size of W, and that's not on the center, so we have these two overlapping shapes. Okay?
So I'm going to jump in here and say that you should try to be explicit with your unions because the renderer will lie to you. They will look like they're aligned exactly, and if you are zoomed out too far or something, and you think, oh, they're magically aligned, and then you generate the model much later, and then you have it 3D printing, and you're like, oh, it didn't quite come all the way up to this.
And I'll talk about that in a couple slides. Spot got ahead of me there. Yeah, explicit unions, they're especially useful when you're doing other Boolean operations.
Quick question.
Yeah.
So when you say Boolean, this is coming out. So basically, the starting point for both the circle and the square is origin.
Yeah, so there's nothing before the circle and square. So this is the union of the two shapes. If you were to go in and say, is any point here inside of this, it would say yes. So think about data, right? If you're unioning different.
Circles when they draw, their starting point is the center, and they draw out from the center in all directions to the circle. When the square is drawn, it draws out in the X and the Y from the starting point. They both have from the both sides. Unless you override it with the center guy.
Which we'll look at that in a second too. Now, the more interesting one is where we're talking about differences. So a difference subtracts child number 1 plus from child 0. Okay? So the order is incredibly important in this, right? So we have circle, and we're going to subtract the square that we had from it. Okay? So this is a Boolean operation. And the only difference between these two was the difference between union and difference. Same code. Now, I said the difference, that the order makes sense. Let's reverse the order of these two children. So now I'm subtracting the circle from the square, and we have the inverse of that. Okay, so it's same code, just different order. Square, circle, circle, square. Okay? But that 0th element, I would say first, but it counts on based on 0, and we'll see that later on, is what you're starting with, and you're subtracting everything else. And if I had multiple more below that, it would all subtract from the 0 one, not like some sort of running statement. No, it's linearly down. So execution in OpenSCAD is always linearly down in a given subroutine.
The first one subtracts the second one, and you end up with, say, that. So if you had another one operated, it would
it would always go from the, if you think about this, it's kind of like you union all of the child 2 through the end, and then you subtract those from the first child. It gets confusing because really it should be 0 and 1, but yeah.
Each one gets subtracted from the top one.
That's right. That's right. So,
So, could you embed like another difference in there if you wanted to do it?
yep, that's how you start getting things done. So the question was basically, can you start nesting these things together? And absolutely, that's how the world works in OpenSCAD. So this is where, we Spot uttered the words turtles all the way down. And it's Boolean operations all the way down when you start getting into really complex geometry. And the third Boolean operation is intersection. And that's where you find where two volumes overlap, right? So in this case, the order doesn't matter because it's just all the volumes overlapping each other, right? So if I had a bunch of different things, let's say I had like something coming off this side, it would say, okay, that's fine, but as long as the volume doesn't change that volume of the overlap between the two of them, it's going to produce the same shape. Okay? But you can start nesting these as deeply as you want. Everybody with me? Okay. Let's move into the hardest thing in OpenSCAD. I have run polls and talked to people individually, talked to the maintainers. The hardest thing that there is not making a mess of the code in OpenSCAD. People have told me I've been using OpenSCAD for years and I can't manage to read my own code 6 months after the point. Spot is like nodding. He might know of some examples of this. And I've thought about the problem a lot. And I think you have to have a lot of discipline in OpenSCAD to make readable code. There's a lot of functional but poor code quality, which means that it's like really hard to manipulate. It's impossible to understand by anybody else. No one will want to collaborate with you. So I want to give you somewhat of a solution to that today. I've used this in a couple of different things, and it does tend to work. And then when I rearrange code for other people's code and to show them this, they say, this has worked to make my code much cleaner. Okay? So you have to be really disciplined in structuring your code. Define all your literals, so anything that you're putting a value in, at the very top of your file. This gets around OpenSCAD's weird, this comes down before this. Just treat it like it's an old school programming language where you have to declare all your variables before you start using them, okay? This is just your literal variables, okay? The next thing you're gonna do is start calculating your variables in the next phase. So here is where you're gonna have some sort of calculation that you're doing that you're not putting into a function, but you're putting it there because you need to have all of it there and you can see those things and it does make sense. Then you start drawing all your geometry after that. So this is where you're going to maybe run a few modules that you've created, difference some geometry, so on and so forth. Okay? Finally, at the end, below everything else is where you define your modules and functions. Because remember in OpenSCAD, we can call a module higher in the file than it was defined, right? So we have everything, all that stuff pushes down to the bottom. That will make your code much more organized. And if you want to, you can go and abstract this away really easily without changing much of your code into a separate file. So you can include or use the files. So it really helps structuring everything if you follow this very specific thing. So literals, calculation, geometry, user-defined modules and functions. Yeah?
Why not the module definitions before you call in the module?
Yeah.
To me, that seems more like.
Yeah. So the question was, why not put the module definitions before you start creating geometry? Because they can get quite big. And when you're creating this geometry, you're probably going to want your variables much closer in the file than you have anything else. And because, and we'll get to the next step, there's a reason why you will never have to look at your literals, things you define literally, in your modules. So let's go to the next step, and we'll make more sense. Literals, yeah.
You're using double slash for comments.
Yes.
Is that necessary? Can you use, like other language, use the tic-tac-toe sign?
Yeah, so that was a great question. I don't think I ever went over comments. Comments work like most other programming languages. You can use // if you want to for a single line comment, or you can use /*, closing with the opposite, */.
So it's C star comments.
it'll reject it, like we should do with most things Python. Not a Python guy. That's okay, I know it. Python SDF is not for me, but that's fine. Okay, so let's go into the next thing about this. Use literals, I can't talk. Use literals as parameters very, very, very sparingly. So that means if I would say circle, D equals 10, FN equals 30 or something, the FN's probably okay, but when you're saying the D equals 10, that is probably a code smell you don't want to do, because the whole point of OpenSCAD is that we can go in and change those parameters and have the magic experience of being able to recalculate everything and re-render everything. Few exceptions, rotational degrees. Everybody knows what 90, 180, 270, and 360 means. That has like specific context in our society, so we get that. Increments and decrements. I don't want you to like start with define 0 equals 0 and ZERO. Like, you don't need to do that. Everybody knows what that is. In indices as well, when you're starting at an index of 0, that makes sense. Sometimes you're going to say index 2 or 3. That will make sense for the most part. Calculate outside of your functions and module parameters. So when you're calling a function, don't say circle D equals 2 times 28, or even A times B. That's usually a code smell. Instead, what you could do is put that into some sort of pre-calculated or function that you would use to pass things in from it. So you're going to look at something, and you should never look at something and start going, okay, this is 10, this is 20, this is 30, this is 40. You should look at it and it should read. Using variables is great. Use functions whenever you can. It makes sense only when you're going to be passing in other parameters, though. So I do still use variables for ad hoc calculations. And the most important thing, never, ever, ever repeat yourself. It is really tempting in OpenSCAD to repeat yourself, and it almost always will come back to bite you. So if you use it more than once, it's worth creating a entirely new function for it or an entirely new module for it. But it creates a new problem of you're naming things constantly, and that's incredibly hard. So sometimes you're going through and going, is this a bracket? Is this a gusset? Is this a support? Is this a whatever? But you will have to like come up with names for a lot of different things and come up with your own naming scheme. I don't have an opinion there. Okay. Let's do an exercise. I've thrown a lot at you. We're still in 2D. We start with a width of 10. That should be the only literal you need to define to create this drawing. Okay? Everything else should be calculated from this. So you will use intersection, difference, square, circle, and translation to create this shape. And try not to repeat yourself and use modules and functions as needed. Okay? 15 minutes to do this.
You said that we're going to be able to get the slides later. How do we get the slides?
I think that Scale provides those on the page. If you look at the Scale website, there's a page for this session. And then at the end of the session,
There'll be some link in there later,
yeah,
and you upload them?
that's right. I've had names like the big one, the small one.
My favorite was a program I was writing that the module I ended up using was the actual correct one.
Yeah. We have 20 slides left, so we're good. Okay, let's take a look at the solution that some of people got it, which I was really impressed by. So Booleans, I thought are really challenging for everybody, but some people like got it straight off, which I love. So here's the solution that I came up with on it. So we did have one literal, w equals 10, and then I decided I wanted to abstract that out because I want to get a quarter of that, so quarter w is the other thing that I used. Let's go all the way to the bottom and look at the function. Now, I noticed when I was doing this that I was repeating the same unit over and over again. So I created a function called x and y that I pass in a unit, and it would give me a 2-element vector back, so I didn't have to repeat myself over and over again. Instead, I could just pass this function in, okay? And then I have my leaf circle, which is just the circle itself with a diameter of w and then the facets of 30. You didn't have to do that, it just makes it more pretty. So we have the square that I created, but let's actually go deeper first. Let's look at the circles. So what you can see here is I have translate x and y. I'm going to use unit here for quarter w. So that would be w divided by 10. And then here I'm doing this by negative quarter w. Okay? So that's creating the two overlapping circles that we have that create the leaf. And then I'm taking the square of x and y with a width of w and a height of w, and I'm centering that, and that's creating the outer one. So you have this leaf shape being subtracted from that square. Okay? Most people got pretty close to that. Maybe the extra abstraction was not something that you thought of, but always find places that you can not repeat yourself, right? That's going to make your code shorter. It's going to make your code more readable. Let's finally talk about 3D things. We've talked to this for all day, and we haven't actually got to 3D. At this point, everything has had no Z. It has been an illusion. There's been no thickness. Let's actually create something. There is a thing called linear extrude, and I'm going to use some props. Linear extrude is just like what you think about it. If you were a kid, this will work, and you used a Play-Doh machine and you pushed Play-Doh out a die and it made like the spaghetti, that's an extrusion. And when you do linear extrude with just a Z value, you're taking a 2D shape and effectively pulling it upward. So like this is kind of like a 2D shape that does have real thickness. but imagine taking a 2D shape and somehow adding thickness over the top of it. Now, you can set center true on a linear extrude and pull it in both directions, right? So imagine if you did a 10, you would go down 5 units and up 5 units to create a linear extrusion, right? There is a thing called rotate extrude. We will reference it. I'm not going to get into it too much. It's very interesting, though. That's where we're extruding things like this. If we want to get this and turn it into a cylinder, we can rotate it around. But it's a bit beyond the scope of this particular talk. So here's an example. This looks pretty familiar, right? This was the same examples we saw when we were doing our union. But instead of doing that union, we are doing a linear extrude of height h on the two things that are inside of it, pulling it up in the positive direction. So here, we're taking the 2D and moving it into 3D. And we can do this to any 2D object we want, right? But there's also a 3D subsystem where we can work directly with 3D primitives. So, and they all kind of boil down to the same thing. A sphere is just a rotated extrusion of a circle. So we take, imagine like a coin, a quarter, and rotate it around the one axis, and that would make a sphere, right? So we just have to provide a diameter or radius for it, and then that will produce a sphere for us. A cylinder, on the other hand, is a linear extrusion of a circle, but we can just call it a cylinder. You give it a diameter, radius, and a height, and it will go and create a cylinder for you. But you can also do it with a D1 and a D2, or an R1 and an R2, to create a conical. So you would have maybe a smaller top and a larger bottom to kind of create a cone. And we supply a Z value as well. Cube is square. Again, mattingly, it's not actually a cube. It would be a rectangular prism, technically. But we go along with the wrong naming scheme that OpenSCAD has. We supply it with a size, just like square, we supplied it with a 2-element vector. We can call it size, but we'll supply it with an X, Y, and a Z. And all these accept a center parameter to make sure that all dimensions come from the center point versus the positive X, Y, and Z coordinates. But I think that sphere is unique in that it doesn't actually, even if you center it false, it won't go in positive in all directions. Don't quote me on that. I know it is a little bit weird that it's kind of like always natively on a center point. So a simple example, this again, it looks like our example before, but instead of using a linear extrusion, we're using cylinder and cube instead of circle and square. Now, we can do our Boolean operation. Okay, a question.
So should there be a union here?
It's implicit.
So in this case, it's implicit.
Yeah. In all cases, it's all cases,
As long as they're together, okay.
as long as they're together, right? When you print this out, it will be one volume. Spot thinks that we should do explicit unions everywhere, but I think that's old.
I mean, so in a simple example like this,
Yeah.
it's fine. When you have a very complicated set of code that has a lot of different shapes that are nested, that are changing depending on conditionals, having explicit unions will save you later.
Yeah.
They look good in the render, but it's off by just enough the printer won't put a layer there, and you're like, oh, I really didn't.
Yeah, there is some. I will say that the interesting thing about OpenSCAD is that it can be so exact that it drives you crazy. Like I was rotating we'll get to rotate in a second. I was rotating a cube, and then I realized that when I went to print it, it printed like one single line because it kind of went over the axis point. You can get into a few things like that. But we're going to look at in just a second Boolean operations and some of the dragons that exist, right? So we can do the Boolean operations just as we would normally do in 2D operations, but now we've added a third dimension. So this is a little bit different than our last examples. They're very similar, but so we have a cube of width W, length W, and Z of H, and it's centered. And then we have a cylinder with a diameter of W and a height of h. So you start thinking through, and it's centered as well. We're going to take a square, and we're going to punch a cylinder out of the middle of it. That's what we're kind of looking at here. That makes sense. So if you were to run this code, this is the garbage that you'll see. This is called Z fighting, or Z fighting. Here what's happening is the height is the same for both the cube and the cylinder, right? So you start thinking about what's happening from a rendering perspective. It's going through and rendering every single picture that or every single pixel that it sees, and because we're working with all floating point numbers, it's not always going to render deterministically. And if I was to rotate this around, it's just a photo, it would start moving, it would glitch in different ways, right? So where Spot was talking about unions and explicit unions and a few other things like that, having this artifact on the screen can be a very important sign that you will get into a non-manifold problem. A non-manifold geometry is where we don't hold water. So, keeping that in mind, we can get around that very often in a final render. OpenSCAD will warn us if we have a non-manifold geometry. It would be very difficult to find out where that is. The final render of that same model looks fine. By the way, when we do a final render, our normal render is F5, our final render is F6. And we can do renders all we want to. They're slower for complicated models, but we still don't want in preview to see that Z fighting. So we have this thing called epsilon. This is something that throws a lot of people off. It makes them irrationally angry that they have to do this. Believe me, I've heard this. There's people who refuse to use OpenSCAD because they don't want to put epsilon in, but epsilon is used in lots of 3D work. It's not just an exclusive OpenSCAD thing. So we're adding a negligible amount of volume to make something a decisive difference. So let's walk through this code. It's the same as everything else, so we've added this epsilon to equal a very small value. Your 3D printer will not render 0.1 millimeters, so don't worry about it. In this case, we were not even going to render it anyway. Yeah, I know. What is that, a hundredth of a millimeter? Yeah, no, I don't. I think you're good if you're getting a half millimeter, right? Yeah. So here, what we're doing, this is the same as before, but our height, we've added epsilon times 2. The reason we had epsilon times 2 is because we have a centered point, and we're pulling it from both sides. We want to make sure we have enough material to remove decisively that piece. It may work if you just do plus epsilon, but it's best practice to, if you're doing centering, you're doing something on both sides, so you epsilon times 2, right? So functionally, it makes them slightly bigger, and if you really think about this, if you're doing like the subtraction, it's not like drilling a hole. Instead, you are like taking a volume out from another volume. You're making a very specific and correct way to remove that volume.
Should the diameter also be minus epsilon?
No. Well, okay, so I did cheat a little bit here. When this happens, this will reach the corner of the rendered output, and you probably will get a manifold problem out of it, but just for simplicity's sake, you would want to make it slightly larger. So yeah, you're technically correct, which is the best type of correct. Yeah. But typically you would never have that. That's not an object that we'd really want to do. We'd want it to have some wall thickness, right?
Right, if I tried to do that, I'd probably end up with 4 triangles.
You'd end up with 4 triangles, right? Because your 0.4 nozzle wouldn't be able to render it. Yeah. Okay, so I had an exercise plan, but I'm just going to give you I want you to get to the final project, so I'll show you what I wanted you to do. So create this kind of like drill bit holder type thing. It's a little bit challenging because I want you to do this parametrically, where you have diameters of 2, 3, 4, and 5 with a center to center distance, and the cube is always wider. And then if we were to go and change these values, it would also work. So let's take a look at the code just for simplicity's sake, and I want to get to a couple other things. So here I set the center to center spacing. The count is 4 and the smallest is 2. So we want 4 holes, and then the smallest one is a 2 millimeter diameter. We're using those units. And the thickness, so the height is 5. We have an epsilon value, and then our width is interesting because we're taking the count plus the smallest to make sure we have that, and then we can add thickness to it. So we're translating the thickness to thickness minus C divided by 2. So we want to make sure if we looked at this, it goes past the negative point. So that's why we're going negative in our translation. And then we are using we're not using a center point here because we wanted to kind of get a weird offset here. So we're doing half of W to get the position on the Y coordinate, and we're not doing anything. We have a cube here of center to center spacing times count. So 10 times count of 40 with a thickness of 5. So we created a 3-dimension object. And then we're using a for statement, kind of starting from 0 to count minus 1, because we were saying we want 4, but we need to get to 3 inclusive, right? So 0, 1, 2, 3. We translate center to center spacing, multiplying by 1. And then we're taking epsilon out. So this is another kind of new thing. If you look at it, we're going down, because then we're going to pull a cylinder up through it, right? So we have a cylinder of diameter I plus smallest, so it's going to go 0, 2, 3, 4, and 5, with a thickness plus our epsilon value, and then we had the facet number just to make it pretty. Okay. A few more slides, and then we'll get to the kind of capstone project you can work on. Rotating is totally possible. The way you rotate is, it's something like translation, where you have a value that you want to put in 3 different things. You're rotating along the X, Y, and Z axis, and it rotates at the children. Now, people get caught up when they start to use rotate, and I'll show you why. So we have a cube of the size that we've specified here, and we're rotating it 45 degrees. So it's just standing up at 45 degrees along the x-axis, right? So this is our x-axis coming towards us. So that works more or less as we expect. Now, what happens if we do rotate and translate at the same time? And we're translating in the Z direction 15 items. And you can see here, it's not, this is the axis it should be on, but it's off in weird space. What's going on here? It has to do with the order that we are rotating and translating. So in this, if you think about it, the center point, we're going, and first thing we're doing is translating negative 15, right? So if we were to remove this rotate, the volume would be just 15 down, right? But it wouldn't be rotated. But the rotation is occurring at the center point, so it's rotating out from the center point, right? So what you have to do to get probably what you're after very often is make sure that you're rotating first and then translating, right? Because we go back 2 slides, we want to make that go down 15. We have to translate it last, right? Does that make sense? It's a little bit confusing.
Right, so the translate is the kind of parent that says, translate what's inside here. And inside here is the
Yeah,
twisted around.
right, right. So
Go to the lowest level.
Yeah.
And do its thing and go back.
that's right. So it can be really hard to kind of think about these things. You're like, do I need to rotate or translate first? But I kind of like to do it in stages and go, okay, I need this thing needs to be rotated 45 degrees, but then I need to position it afterwards. If I position and rotate in the other order, it's going to give me a result that's rotating around a different axis. So let's talk about hulling. Hulling is a very important concept. Well, joining objects, rather. It's called hulling. We have these 2 objects kind of floating out in space, right? We have got a sphere down here and a little cube up at the top. This is not really amazing code. It's just translating to 3D objects. If we want to join these, how would we do that? It doesn't make sense that we would use some sort of Boolean operation. What we'll use is a thing called a hull. A hull is a module that will take the outermost edges and join them between multiple objects. See what's happening here? All we're doing is adding this hull in. And what it's doing internally is taking the polyhedron that's represented by this and then finding the other points where it can stretch those 2 together. And you can do more than 2, you can do as many as you want. So it's a,
Does it always have to be a straight line, or is there a parameter?
the question is, does it always have to be a straight line? It will always be a straight line. And then the question is, can we do more than one? We had a question about somebody in the back, I think, wanted to do an aircraft and said, I have these 5 segments where I do that. And that's called a chained hull. So you will go through and hull the first one, and then hull like the 0th in the first one, the first and the second, and then you would do a union on top of those pieces. There's a thing called epsilon hulling, where you basically create 3D objects with the smallest possible thickness, so an epsilon value, and then you hull those together to create different shapes in that exact method. So then you would chain them together. So they have a thickness that is imperceptibly small, but you can create really complex shapes that way.
Can you do rotation? Or is that a different?
I'm not covering that, but you can do some rotational things, right?
Threads or whatever?
Yeah, of course, of course. That's usually done with the for statement, though. Yeah. Okay, or a library. There's libraries for that. Speaking of libraries, if you're interested in libraries for OpenSCAD, it can get you past a lot of this boilerplate stuff. There's a few out there. There's Bosl 2, BOSL 2, that has a lot of this stuff built into it, and it does things like attachments and some other really nice features. It's a very extensive library, and it's constantly changing. So they don't quite have, it's still in beta, so they don't have like a solid version number, so you can kind of like download a new version and get a surprise. But it's like a standard library replacement for OpenSCAD. It's very helpful. And it can do threads. It can do all sorts of things like that. And there's other ones that will give you all sorts of other things. So how do you 3D print this stuff? We talked a little about to begin with. F6 to render, and that'll give you your final render. You do F7 or use the command line to produce a STL. They are by default ASCII STLs, which are gigantic. You can then change them to binary optionally. I don't know the advantage of an ASCII STL besides debugging, but they're accepted by any slicer. There is an option in OpenSCAD where you hit F8 and it says send to Octoprint. Doesn't work. The reason why is Octoprint took out the standard slicer built into it because it's really buggy and we're not that great. There is some talk and people bring up perennially Clipper having a built-in slicer and sending it to Clipper. That would be nice. Fingers crossed, let's all get there. The one thing that I will say that I tend to like to do, because we're dealing with parametric stuff, my design process is to start with no measurements, right? And just kind of get my shapes together. And then when I actually go through and put it in, I start putting in the parameters that I want to have. So for example, embedding your print settings directly into it. So you put your wall thickness in as something that would be relative to your nozzle. So for example, you might put your nozzle being 0.4 millimeters, right? But if you do a wall of 1 millimeter, that's not going to print correctly, right? So you put in your nozzle diameter in as a parameter in your OpenSCAD file, and then you can always be sure that you're going to get an exact full perimeter width, like unit, I guess you would say. First layers, my hobby, the thing I like to do is build foldable designs. So I use the first layer thickness very extensively so I can create these origami-like designs in OpenSCAD. So it can be really, really helpful. Now, we are almost at the end. Before the capstone, which you can spend as much time on, I don't know when they're going to kick us out of this room, but we're almost at the time. If you are a C++ programmer, the OpenSCAD project needs contributors, specifically for things like releases, automation, and testing. Right now, they continually add features, but those features are hard to get into a release. You notice we used 2021-01. That was the last major release. The developer release has come really far, but they need a lot of help when it comes to doing the releases. So make sure you follow us on social media. I'm here on all these things. Please come to my talk tomorrow if you're interested in mutability. But then I want you to do the capstone exercise. We have a few minutes left, and I want to explain that to you. I want you to create a table. The top dimensions can be changed via customizer. The top thickness can be changed via customizer. The height of the table can be changed via customizer. But I want the legs to be twisted. The bottom is slightly smaller and twisted at 45 degrees. And then your stretch goal is to make it have any number of legs. specified through Customizer. So as an example, here's what this looks like. A little bit hard to see in the contrast, but you can see this has a slightly twisted leg. Might be seeing how we might use maybe hull to do this. We have a table of 4 legs. And here we have the multi-leg model, and I just in Customizer was able to be able to put in, I want 2 legs per side, 5 legs per side, whatever, and it should be able to generate all that. So that's your challenge to leave with. I'll stick around if you have questions, and if you want to work on it a little bit, I'll stick around a little bit further too. They may kick us out of here though. Thanks, folks.